So now we're actually going to talk about what are the titles of this unit, the unit circle. So what it is and where it comes from. This is going to be something you're going to be working with quite a bit through the course of this unit. So the unit circle is called a unit circle because it has a radius of 1. So a circle that has a radius of 1, aka 1 unit. So think about this. We have unit rates like miles per hour. That's miles per 1 hour. So when we talk about unit, typically that implies we're talking about 1. Thus, unit circle, radius 1. The unit circle is centered at the origin, aka 0, 0. Angles in the unit circle start on the positive x-axis at 0 degrees. So the positive x-axis would be, if you're thinking about this would be the positive x-axis, and that means that is 0 degrees. And the counterclockwise direction is positive when measuring angles, just like when we talked about rotation. So positive is counterclockwise. Okay. Now, contain 360 degrees, 1 revolution or 1 time around. So if you go from start to finish, that's 360 degrees. So you'd have 90, 180, 270, 360. And you can keep going. We'll talk about that in a different video. Certain angles in the unit circle have a particular coordinate on the circle associated with them. So if you think about the unit circle, it's this circle, right? It has a radius of 1. And on the circle means on the actual circle here. So there are coordinates, right? And for each of these coordinates, right, there'd be a certain angle associated with that coordinate. And that's part of the relationship, the big relationship we're talking about in the unit circle. Okay? So how that comes about and what some of these special coordinates are. So setting the stage for the unit circle are special right triangles. There is a reason, right? So special right triangles that have a hypotenuse equal to 1. The reason is this way they will fit inside the unit circle. So we're going to kind of tease out some of these, what these coordinates are. So if this is 1, we know that we have to divide by the square root of 2. Right? So this is 1 divided by the square root of 2, but we had to rationalize it. So we multiply by the square root of 2 over the square root of 2. So we get the square root of 2 over 2. And that is what this side length is here, which means that this side length is always also the square root of 2 over 2. Now, this is the hypotenuse, which is 1 here in the 30, 60, 90, which means that this side length is 1/2. We divide by 2, right? Here we then multiply by the square root of 3 to get the side opposite the 60. So this is 1/2 times the square root of 3, or the square root of 3 over 2. Remember, square root of 3 is square root of 3 over 1. So that means that these are the side lengths of right triangles, special right triangles, that fit inside the unit circle. So these numbers, the square root of 3 over 2, 1/2, and the square root of 2 over 2 are going to be ones to remember. You're going to see those a lot. Okay, so here's how that sets up. A unit circle. So what I've got here is a unit circle, right? So what we can do is, remember, this represents 0 degrees, right? This represents 90, 180, 270, and then this would be 360. 360 and 0, obviously the same thing, once around. Or nonce around, not that that's a word. In any event, what we can do is we can start tracking around the unit circle with a bunch of special right triangles that fit inside of the unit circle. For instance, this would represent a 30-degree angle. See, that's 30 degrees, 0. So this would represent a 30-degree angle. And there would be a certain coordinate associated with that. So remember, this side length is the square root of 3 over 2. So that would be the x-coordinate. That's how far over you'd have to go. So that would be the x-coordinate there. And then this side length would be 1/2 from our previous work. So that would be that there. Okay. Now I don't want to get this too cluttered, so I'm going to move this then out of the way. But that would be where that point is on the unit circle. Okay. And then if I move to the next highest angle, 45 degrees, see how that nicely fits inside there, right? That's another point on here, and that would represent a 45-degree angle, right? 45 degrees from the 0, counterclockwise. So then this coordinate would be the square root of 2 over 2, square root of 2 over 2, because this side length is square root of 2 over 2, and this side length is square root of 2 over 2. Okay. Now, then the last in this first quadrant, right, would be a 60-degree angle. So we had a 30, 45, and now we have a 60-degree angle. And that would be, well, that side length is 1/2. Remember, this is just the 3069. It's just turned a different way, right? And this would be the square root of 3/2. So now for these angles in the first quadrant, we have certain coordinates associated with them, right? Now we can keep going. So if we were to go to here, come back here, right? Now this is where we need to be a bit careful, right? So this is 90 degrees, right? From here up is 60 degrees. So what does that mean? This amount left here is, that would be 30 degrees right there. So what this means is this angle is 30 degrees on the other side of this, okay? So if you think about this, this is a reflection of this triangle right here, right? So if you think about this reflecting over here, that would mean what? Well, this space is 30 degrees, so this space is 30 degrees, which means this represents 120 degrees, and its coordinate would be a reflection over the y-axis, meaning the y wouldn't change, but the x would. And if you look at the side lengths, that makes sense. This square root of 3/2, this is 1/2, but it's in the negative direction, okay? So what happens is you can kind of mirror these different points. Now please bear in mind, this angle is 90, this is 180. All these are going to be increasing, but larger than 90 and less than 180. So when you hit this 45-degree angle, right, I don't know if you noticed, from 60 to 45 is 15. The same thing is going to happen here, which means that this is 135 degrees, okay? And then we can work our way around, so that means that this would be, well, it would have a positive y, but a negative x. So what I'm doing is kind of creating, just for these angles that work with the 30, 60, 90 right triangles, the special right triangles, right? And coming up with these different angles that they represent. So this would be 30 degrees less than 180, right? Or, so I didn't mark that point. I should probably mark that point. It's right around there. It means this point is right around here, and that would be 150 degrees. And its coordinate would be negative √3/2, 1/2. So you can continue this all the way around the unit circle, right? So here, this would be, and it's going to get a little bit cluttered here, but I can continue doing this with these different special right triangles, right? Working my way around and logicking out what the coordinates are, as well as what the different values of the angle are. So this would be 30 degrees more, so this would be 210. This would be 235. No, I take that back. This would be 225, 15 degrees more, 225. And this would be 240, right? It's 30 degrees off. This would be 30 degrees off, so 300. This would be another 15, which would be 315. This would be another 15, so this would be 330. Wow, that 3 needs some help. But anyway, 30 degrees off. So and then these coordinates all end up looking similar, as in there's going to be 3 numbers involved, right? For these different numbers, 1/2, square root of 3/2, or square root of 2/2, depending on what angles we're talking. So if you think about this, this is a reflection. Now in this quadrant, if you think carefully, all these are going to be negative. This quadrant 3, right? Negative x and negative y. And this would be negative 1/2, negative √3/2. This would be, well, the x's would be positive, but the y's would be negative. So if we reflect this here, this would have the same x, the opposite y. Same x, opposite y. And then, of course, this would be 1/2, negative √3/2. So all this information enables us to get the coordinates, based on these special right triangles, of certain angles. And these are going to be the angles you're responsible for. Now, in the end, you will be provided with something that looks like this. the unit circle, okay? We'll have all the coordinates given to you. You don't have to memorize it, but you'll see that this ends up being the same thing with all these different same coordinates, just maybe done a little bit more neatly. So that's where the unit circle comes from, and that's what the unit circle is. We're going to be using the unit circle to find different ratios and different trigonometric identities.